And you're welcome to turn off your camera if you want, just to see the full your full screen there, if you prefer that.
Okay, so how to do that? Let me. Is that okay?
Yeah, looks good. Thank you.
Okay. So can I start to present?
Yeah, please go ahead.
Okay, thank you. Good morning, everyone. I'm Kei, and 2 years ago, I am from Japan and living in Canada. Currently, I'm living in Vancouver, and before that, I was working in Japan about 6 years in forest management related to the LiDAR data. So today I would like to share some information and useful data in the LiDAR utilization of LiDAR data for forest resource management in Japan. Today's my presentation contents is the first one is current status and issues of Japan's forests. The second one is LiDAR data application in forestry. And the last one is future perspectives of the LiDAR applications. So in Japan, the need to utilize airborne LiDAR measurement technology has expanded dramatically in the forestry fields, such as forest resource analysis, development of harvesting support, forecasting the amount of woody material outputs, and real network planning, and also mountain disaster mitigation. Japan is one of the most forested countries in the world, and according to the Ministry of Forestry report on current status and issues on forest, the forest areas is approximately 25 million hectares, which is 2/3 of the national land area. And the accumulation of forest resources, mainly in planted forests, which is 10 million hectares in the forest area, and has increased by about 70 million cubic meter every year, and is currently the planted forest and the natural forest amount is about 5.2 million cubic meter. So this is the change of planted forest age classes between 1966 to 2017. And we can see the change of the class age of the planted forest, where the main forest age over 50 years. So that means the half of the plantation are over the 15th grade, which is the general mean cutting season, and it's very necessary to utilize resources effectively and systematically reconstruct for healthy recycling. In addition to mass...
Sorry to interrupt you. I think we're stuck on your introduction slide right here.
Mine is moving.
Okay, do you have two screens?
I have two screens, yes.
Okay, yeah, make sure to, because you're sharing only one screen, so make sure you move your presentation to the other screen. To the main screen.
Yes, it's on the main screen.
Okay, so maybe you move it to the other screen. I'm not sure.
Okay. Let's try.
Okay, perfect. Yeah, keep going there. Yeah.
From here. Is that okay?
Yeah,
that's
please.
Moving. Okay.
Perfect. Thank you so much.
Okay, so can I continue?
Yes. Yeah, this is awesome. Thank you, Kate.
Yeah, thank you. Sorry about that. So as I said, the half of the plantation are over the 15th grade, so it needs to be addressed, and the problem should be solved by using the LiDAR data for management of the whole forest area in the large area. And actually, it's a good thing for how this over age 15s in forestry. It's the very plenty of the resources, but on the other hand, the overpopulated forests are very problematic due to the lack of forest labors and also the hazardous environments of Japan. And the one of the overpopulated forest resources can have caused the degraded forests where the surface soil flows out due to the lack of forest floor vegetation, which is the result of not carrying out the thinning properly. So the ideal forest condition is where the thinning is carried out and the direct sunlight shine into the forest, and the forest floor have the enough vegetation covering and maintaining the water recharge functions. So the governmental organizations and the private companies are collaborate to maximize the utilization of LiDAR data both in infrastructure information and forestry. Here is the map of the LiDAR data coverage in forest area. But, initially, these data is just for the infrastructure, the public surveys. But after that, the governmental and the private organization realized that these kind of data is very important for the forest management skills. So it's in 2017, it's already covered the more than 50% of the forested area. By now, it is up to 70% for the whole country. So as any other country, in Japan also the application of LiDAR in forestry are below like this. The acquisition of precise forest resource information like the tree heights and the dBH and also the volume and the number of stand, the stand density. Another important one is detailed topographic information and extraction of degraded forest relating to the stand density and other topographic information, and plan lodging and simulating the future growth, calculate the amount of log materials, forest zoning, road location planning and analysis, extract potential mountain hazards area, and also management of the mountain restoration facilities. Today I would like to talk about the second one, the acquisition of precise forest resource information and also the detailed topographic information. The basic data from LiDAR is the digital canopy surface model and the digital elevation model and the digital canopy height model, which is the result of subtraction of the digital canopy surface model and the digital elevation model. These are the main process production of airborne LiDAR data and also the orthophoto. By analyzing the DCHM, forest research information such as tree species, tree height, and volume stand density can be graphed effectively and accurately, which is critical in forest management and planning. In the analysis, the first stage is to create the forest phase map, which is show the tree species. For Japan, the main tree species is Japanese cedar and the Japanese cypress for the planted forest. So it's very important to acquire these information, the area of the species and also the location. So in conventional method, the forest phase map is created by interpreting just the ortho images where the interpretation is often very difficult for cloud shaded area and drawing parts of the photos and photos with high gradients. For the purpose of acquiring high accuracy forest phase image effectively, a new method which is called a laser forest type image was generated by combining LiDAR derived information like the reflection intensity, the tree height, that is the DCHM, and also another one is the crown shape index, which is different in each tree species. In the laser forest type image, it's very easy to distinguish tree types easily because the different tree appears in very unique colors and texture. Like in this image, the Japanese cedar, it has a very sharp texture and a very bright top and also the orange color. Whereas the Japanese cypress, it didn't have the sharp texture as the cedar, but we still can distinguish from the pink color. But in the ortho, it all looks very green. That means it sometimes, in the first look, it looks like the same tree species, but it's not. And the laser forest type image will provide very effective visualizing of the forest phase. After creating the forest phase image and the next stage, individual tree detection analysis will be performed for planted forests such as the Japanese cedars, Japanese cypress, and also the red pines. The position and height of each single tree will be obtained by this process. And in addition, the diameter at breast height, the dBH will be estimated for each single tree with a regression equation that is created by the correlation of the canopy area calculated from the BCHM and also the DBH obtained from the field survey. The volume of the individual tree will be calculated from the obtained tree height and the DBH using the formula. And the extraction of the tree height and also the DBH have very high accuracy and the relational coefficients. For the tree height, usually it has the root mean square about 1 meter, and for the DBH, it has the root mean square within the 2 centimeter, which is very high accuracy in this field. So by aggregating these acquired information for each tree in display, within it's possible to calculate the stand density, average tree height, and also average tree DBH and volume of the forest subgroup or within and the range. In Japan, it's like the forest management unit is called counterpartment. In each counterpartment, there also have some subgroups. By acquiring every individual trees and aggregating and calculating these trees information, we can visualize these data by GIS database and also creating mapping for the decision making. So after analyzing the forest resources, and there is one very important way to see the visualizing forest microtopology. Usually, LiDAR-derived TM can be used to calculate target areas, contour data, slope, and aspect. Then there is one of the LiDAR-derived TM microtopology map. It's called Rapid Relief Image. It's now very common and very popular in Japan because it's very useful for detecting the hazardous area and debris flow and landslides. This new visualization method is based on multi-layer topographic information computed from the VM, and it can visualize the topographic slope and other concavities and convexities in the same time. And it doesn't require any specialty of geomatics or mapping information to understand the detail of topographic information to the image audience. The bright colors here is the ridges and the dark color is the hills. And sometimes we can detect some potential risk areas under the forest cover by looking at this kind of vertical image. And sometimes it's used for the dam and inspection the roads and also the slope works where they have the problem or not. And it's very clear to see these kind of restoration facilities from this image, and it's a very direct way. And it's also possible to manage the existing storage facilities, identify the mountain disaster risk area and collapse, and estimate the amount of runoff soil. It's also very effective for grasping cracks caused by earthquakes, which is very common in the Japan forest. In addition, it's very possible to predict the occurrence of driftwood disaster, which have been increased in recent years because of the heavy rain, and to formulate countermeasures. It can improve the forest fieldwork very efficiently by giving direct visual references, since the topographic map created from the aerial laser measurements have extremely high topographic reproducibility. The actual measurement work can be very simplified. So the last one is the future perspective of the modernization of forest management that now called smart forestry in Japan. So that means acquiring data from the field survey and also airborne LiDAR scanning and getting the very detailed topographic information and also the resource information of the whole forest area by surveying, and then visualizing and managing the information by the mapping into GIS, and according to the attribution of each counterpartment or the management unit to predict the future condition or future zoning of the forest function zoning, and to planning the roads and other restoration facilities, and to achieve the sustainable management of the forestry. And by providing these information to the operation side, they could have the management planning for the road planning, also the thinning. They can update their operation history and of the recording the cells after recording to the system. And finally, there is one evaluation about the whole system. That's like a PDCA cycle. That means plan, do, check, and action. By doing this to achieve the forest big data and also to achieve the smart forestry in Japan. This is actually the future perspective of the Japan forestry management. So at the end, I would like to give the advantage of LiDAR data we're in using in the forestry management. The first of all, it's the diverse information is used for forest evaluation, like the tree heights and also the different topology information. And recently there is some researches about the combining the topographic information and also the site index to zoning the forest area and to achieve the future prediction, and obtain information from places that very difficult to access. Like in Japan, it's very steep and in the mountain area, and the slope is very steep. So this would be a very efficient way that is very labor saving. And wall-to-wall birth information of a large area can be calculated in a very short period of time, and labor saving and enhanced accuracy than existing the methods. And the information of analysis data, field data, and of geographical and topographical information can be consolidated, simplified information management. So the GIS analysis using centralization of the information management, like the collecting all the data in one database for the whole forest management, so that the governmental organizations and the field operations and also the users of data, like the forest owners, can use and can have the data from the one whole system. So this is all for today. Thank you for listening.
Thank you, Kei. That was really, really interesting. Thank you so much. You're welcome to turn on your camera here to answer. We have 1 or 2 minutes for questions. You can welcome to turn on your camera if you want to answer a few questions on camera. But Jonathan Murphy of Go Geomatics say that you have a great article related to this, Japanese perspective, LiDAR forest data for resource analysis in Japan. Jonathan. So he posted a link on the chat. Someone asked, the Japanese visualization techniques with LiDAR are very cool. Have you tried them with the Canadian data?
Actually, I haven't tried these data yet because I started to work for the 2 months before. So I am really new for the Canadian data, especially for the LiDAR. So in future, I would like to try this visualization method for the Canadian LiDAR data for the topography and also the forest LiDAR images. Thank you.
Right on. One more question, and then we'll move on to Lucas's presentation. Roger Weed from UNBC asks, well, he says, impressive coverage of forests in Japan. Which areas are currently missing? The more mountainous areas or more remote islands?
That means the deforestation, which is also missing the more mountainous areas.
I'm not sure what he means.
Well, what kind of things missing? Which areas are currently missing? The more mountainous areas. If it's about the forest degradation, it's more than occurred in the mountainous area because the slope is very steep in the mountainous area. Usually, if we try to go to the field survey, sometimes we can see some kind of slope more than 40 degrees. It's really hard to do the field surveys. And that kind of conditions and also the very dense population of the tree cause some kind of forest hazards like the landslides, a very big area of landslides. Every year, about the June and July the most, the heavy rain season. It always occurs, and so very large scale landslides are happening, and also very much people are influenced by that kind of thing. So no, for Japan, it is the very important and also very prioritized thing to prevent the hazard, and by using and utilizing the LiDAR data and to quick response when the hazards that occurs.
Great thing. Oh, sorry.
There is one thing that which area don't have the LiDAR coverage. I think if for the LiDAR coverage, I think it's the isolated islands. Because the coverage for the LiDAR, it's the main purpose is for the infrastructure, the within or the around the cities, and also the forest area. Also, it's on the mainland. So I think the LiDAR coverage didn't cover much better of the isolated islands.